Hello everyone. This is a brilliant question of a complex combination of the resistors. If we look carefully, here we have a battery. The battery's EMF is given to us as 12 volt and the battery's internal resistance is also mentioned as 0.5 ohm. Then we have the resistors connected like this and the sequence keeps on going up to infinity. Now we have to find the current. This is our target. We have to obtain the current. We know one thing, the current I will be equal to V by R equivalent. Here V is known to us. Now we need to find the R equivalent. For finding the equivalent resistance, let us focus on this. Suppose we look at this combination, this one. We don't know its resistance, it goes up to infinity. Let's say we imagine its equivalent resistance is X. Whatever we don't know, usually we assume that X in the mathematics. Now this is a very complex combination. You cannot find anything simply in series or in parallel here in this infinite ladder. So we will consider its equivalent resistance to be, let's say, X. Okay, you get this? Now suppose I leave this resistor and I leave this resistor and I leave this resistor. What I mean to say, I am marking them with a different color. Let's say we leave this resistor, this resistor, this resistor. Just for a moment, leave them. And now look at the remaining. Look at the remaining means we are looking at this. Can you tell what should be its equivalent resistance? Leaving those three resistors and then taking this entire combination, should its equivalent be again X? Because from this infinite network, if I drop these three resistors, even then the remaining resistors here are infinite. Up to infinity the sequence is going. It means this green one, its equivalent resistance is also X. Do you agree? See, if we take this pink one combination, its equivalent resistance is X. Now from that combination, we leave this, this and this. After leaving them, if we look at the remaining thing, it is identical as the previous one. So its resistance should also be X. Now our circuit gets very much simplified. If we look carefully, this entire green resistance can be taken as X. So I am writing here that green resistance X. Across these 2 points, across these 2 green points, the equivalent resistance is X. Okay. After that, we have this resistance 1 ohm. In parallel to these 2 green points, we are connecting this 1 ohm. So I am connecting that 1 ohm here. After that 1 ohm, we have this resistor. So showing that 1 ohm here. And then we have this resistor, 1 ohm here. And we know one thing. We know one thing, that across these 2 points, these 2 pink points here, what is the equivalent resistance again? We take this equivalent resistance again as X, because this pink network, this box had the equivalent resistance X. So across these 2 pink terminals, the equivalent resistance we will show as X. Do you agree? Now, if we see carefully, then we can see these 2 resistors are in parallel. X and 1 ohm are in parallel combination. Okay. Then their effective will be in series with these 2 resistors. So let us redraw the circuit. I am redrawing the circuit here. We have these two pink terminals. After these pink terminals, we have the resistance 1 ohm. Here is also the resistance 1 ohm. Okay. This 1 and X, they are in parallel. If these two resistors are in parallel, what will be their equivalent resistance? You know that it will be 1x upon 1 plus x, R1 R2 upon R1 plus R2. And this equivalent resistance is taken as X. Okay. Now these three are in series. This. They all are in series. And their net equivalent is equal to X. So let us write it on the next page. 1 ohm plus 1x upon 1 plus x plus 1 ohm should be equal to the net resistance X of this infinite network. Okay. So the X should be equal to 1 plus 1x upon 1 plus x plus 1. Agree with this? Let us simplify it further. X is equal to 1 and 1 will become 2. And here we are having x upon 1 plus x. Now doing the cross multiplication, you can treat this as 2 by 1. Okay. So 1 plus x is getting multiplied here. That 1 is getting multiplied here. So simplifying the cross multiplication, x is equal to 2, 1 plus x. This 1 plus x is getting multiplied here, plus x into 1. And then these two terms will get multiplied here. So 1 into 1 plus x. Okay. 1 into 1 plus x will result into 1 plus x only. This 1 plus x is getting multiplied here. So x into 1 plus x is equal to 2 into 1 plus x plus x. Simplifying it further, we are having x plus x square is equal to 2 plus 2x plus x. This is getting cancelled out. Then we are left with a quadratic equation. So x square minus 2x minus 2 is equal to 0. You can compare with the standard expression, which is ax square plus bx plus c is equal to 0. And we can find the root of this quadratic equation. So let us simplify that part here. The x is equal to, if you remember, the formula was minus b plus minus root of b square minus 4ac divided by 2a. Sridharacharya Sutra. To get the root x, we use the Sridharacharya Sutra. Here, the resistance cannot be negative. So I am deleting this negative sign from the computation. Now compare and put up the data. The b looks as minus 2 if we compare. So submitting the data now here, it is equal to minus 2. The b is equal to minus 2 plus the root of minus 2 square minus 4. The a is equal to 1. The coefficient of x square is equal to 1. So putting here 1. The c appears to be minus 2. So let's put here minus 2 divided by 2 into a. A appears to be 1. You agree with this? Now simplifying it further, the x comes out to be 2 plus root of 4 plus 8 divided by 2. So x comes out to be 2 plus root 12 by 2. X comes out to be 2 plus this root 12. I am intentionally writing 4 into 3, and then here we have the 2. X is equal to 2 plus this root 4 will be equal to 2. So the 2 comes outside. Here we are left with root 3 by 2. Let us simplify it again further. Taking 2 common, the x comes out to be 2, 1 plus root 3 by 2. So we have the final data. The x comes out to be 1 plus root 3 ohm. Do you agree? This is the equivalent resistance of that infinite network. I would like to recall the infinite network again. I am talking about this network. From these 2 pinpoints, if we travel here up to infinity, the net resistance of this network now we have obtained is equal to 1 plus root 3 ohm. Now to obtain the current, we'll be putting up the data in this expression. So I is equal to voltage. Voltage is given as 12. Equivalent resistance. Now if we look carefully at this circuit, here at the pink terminals, the net resistance is how much? The net resistance is 1 plus root 3 ohm. Agree with this? I am talking about these 2 pink terminals. Across them, these 2 pink terminals, across them, the equivalent resistance is 1 plus root 3 ohm. Then you have a battery of EMF 12 volt like this, and the battery has got its own internal resistance of 0.5 ohm. Battery's EMF is given as 12 volt. Agree with that? Battery's EMF 12 volt, battery's internal resistance 0.5 ohm. And that infinite network had the resistance 1 plus root 3 ohm. So if we need the current through this battery, then the current I will be the potential difference, which is 12 volt, divided by R equivalent. R equivalent, shall I write 1 plus root 3 plus 0.5, and the SI unit of the current is ampere. See, this 1 plus root 3 ohm and that 0.5 ohm are in series. Now simplifying this, we have the answer for the current.